Good morning, guys. Welcome to another episode of Xah Talk Show. We are going to code Advent of Code, 2025, Day 1, in Wolfram Language. Now, if you are watching this offline, play at 1.5 speed minimum. If you are here, say hi. Love to see your comments. We got 6 people. So starting Wolfram Language, the most advanced programming language. A new notebook. Okay, so we are ready to go. Let's magnify 153, Shift Enter to start the kernel. Okay, so comments. Okay, advent of code. I haven't read the problem yet, but let's do. So we're gonna read it. Okay, so needs to be here. This idiotic advent of code, dark theme, stupid, and you cannot resize it, the window. So they have hard-coded their website layout, which is idiotic advent of code. Okay, so anyway, we're gonna start it, and let's see how far we go. Okay, comments. So advent of code. So let's see today's talk show. So we're gonna use Wolfram Language introduction. If you don't know, search for Xah Lee Wolfram Language for programmers. So you got a complete tutorial from the ground up for programmers, and on xahlee.info, HTTP no S. Okay, and you can then you can download Wolfram Language for free. It began free about 4 or 5 years ago, okay, on this link. And I have like over 100 video tutorials on Wolfram Language in the past. Okay, so go back to today's talk show, and you got Xah Wolfram Mode, which allows you to code Wolfram Language in Emacs. So anyway, let's begin, okay? Xah Wolfram Mode and Xah Fly keys, that's what I'm using. So I'm using Emacs, the most advanced editor for coders. Okay, let's put it back there, put it there. Okay, let's read the problem and let's see, just have fun. Okay, advent of code, day 1, secret entrance. The elves have a good news and bad news. The good news is that they've discovered project management. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations needs to be finished soon so that other critical tasks can start on time. The bad news is that they've realized they have different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. Okay, to save Christmas, the elves need you to finish decorating the North Pole by December 12th. Collect stars by solving puzzles. Okay, 2 puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. Okay, you arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains. Tedious babbling. Then, due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number, okay, 0 to 99. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with L or R, which indicates whether the rotation should be to the left, towards a lower number, or to the right, towards higher number. Okay. Let's see. Wait, 0 to 99. So according to this, the 0 to 99 is arranged counterclockwise, supposedly. I'm not sure. So let's see. Then the rotation has a distance value which indicates how many clicks the dial should be rotated in that direction. Okay, left or right, and the number of clicks. So if the dial were pointing at 11, a rotation of R8 would cause the dial to point at 19. So 11 plus 8 is 19. So, okay. After that, a rotation of L19 would cause it to point at 0. Okay. So far, so good. Comments? None. Because the dial is in a circle, because the dial is a circle, turning the dial left from 0 one click makes it point at 99. Okay, so yeah, exactly. So the numbers are arranged in counterclock orientation. Similarly, turning the dial right from 99 one click makes it point at 0. So 0, suppose, is at the top, and to the right of it is 99. Okay, so turning the dial left from 0, that's right. Okay, so turning left means you rotate it counterclockwise. Turning right means you rotate it clockwise, just like common sense. Okay, so if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. So let's see, 5 L10, which means rotate left, and which also okay, so L is actually so you know, it says decreasing and increasing, but so let's see, how do we model this L10? L10 would cause it to point at 95. That's right, because let's see, 5, a rotation of L10 left. So so if it's 5, let's see, 5, so essentially it's 0 to 199. So you want to do modular arithmetics of 100. So 5 L, so L is negative or positive. L means let's see, let's get this right. That's the heart of solving the problem. Okay, a rotation of L10. Let me just think about it. Comments, guys, comment. Woohoo, maybe make a drawing. Yeah, make a drawing would be great, but then it takes time. So then it's gonna make my video like from 1 hour to 2 hours. but it's always good to make a drawing. Okay, so let's start a drawing. So let's see. So basically you have something like that. So 0, 1, 2, 3, 4. Okay, so this is 99, 98, and so on. L10 means move leftward. So let me think about this. So L basically means minus. So if you are at 5, L10, I got a cold over the weekend, so the whole body aches, so it's pretty bad, and coughing, but now I'm better. So L10, I'm pretty sure it's minus. So 5 minus 10 would be negative 5. Then you plus 100 means 105. Then you modular divide by 100. The remainder is 5. So L10 calls it 2.95. Wait, that's not right. So let me see. So if it's pointing at 5, let's say if it's pointing at 5, so 5, 6, so something like that, suppose. 5, 6, wait. Yeah, it increases on the left. 5, 6, 7, 8. Okay, then 4, 3, 2, 1, 0. Okay, so if you rotate it by 1 to the left, then it's gonna be 4. So left rotation means minus. That we can be sure. So 5 rotated to the left by 2 gets you 3. Okay. Now 5 rotated to the left by 5 gets you 0. 5 rotated to the left, so to the right of 0 is 99. Now 5 rotated to the left by 6 is 99. How do you arrive at that? Because 5 minus 6 gets you negative 1. Negative 1 plus 100, because there's 100 of them. So 101. Wait, so this is involving signs. So if we 5 rotated by 6, so 5 minus 6 gets you negative 1. Now negative 1 plus 100 is 101. Wait, negative 1 plus 100 is 99. That's right. Negative 1 plus 100 is 99. That's what you get. That's correct. Okay. Then 99 is less than 100, so you don't need to do anything. Or 99 divided by 100 is still 99. Okay. So left means minus. Rotate right means plus. Okay. So modular arithmetics, that's a key, which means modular arithmetics is an operator that takes two numbers. Basically, it's the remainder. So one number divided by another number, then you take the remainder. That's what modular arithmetics means. Okay. Okay, so we got that. Close it, save it. Okay, so the day one problem should be easy. Okay, so if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 would cause it to point at 0. Okay, the dial start by pointing at 50. Okay, so there is a beginning of pointing 50. You could follow the instructions, but your recent required official North Pole Secret Entrance Security Training Seminar taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. Okay. Okay, so there's a trick. So I suppose you got a bunch of instructions, left something, right something, left something, right something. And the key is it begins at 50, okay? So left, right. And so what is the problem? The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. It's fucking stupid, idiotic phrasing. Okay, so the actual password is the number of times the dial is left pointing at 0. What does that mean, left pointing at 0, after any rotation in the sequence? You see, this is idiotic English because this is not logical. So the number of times, okay, I got that. It's a number of times it occur. Now, but what's a circumstance? Well, the circumstance is the dial is left pointing. What the fuck does left pointing mean? You see, you got a dial, you got a pointer. What the fuck is left pointing? The dial is left pointing at 0. Does that mean after a left rotation and it results in pointing at 0? Does that mean that the dial is left pointing at 0 after any rotation in the sequence? Well, then what does it mean, any rotation? So it could be also right rotation. So what is the... Oh, okay, so the dial is left pointing at 0. So this is English ambiguity, and the idiot of the advent of a code writer, he doesn't know the ambiguity about English. He doesn't know how to write English. You see, the actual password is the number of times the dial is left on. You know, it's better if you say on. So after the number of times the dial is pointing at 0 after a rotation. Okay, that's a better phrase. The number of times, basically the number of times it is pointing at 0. Okay, let me rephrase the question. So you got a dial, and you got a then you got the instruction, it begin pointing at 50. Okay, then you are giving a bunch of rotation left and rotation right. Okay, now after all that, the number of times, every time after rotation, the dial is at 0. The number of times, so that is a number. And that number is the password. Okay? So this is the stupid phrasing. Okay? So for example, so let's verify. So he's gonna give you an example. That's right. Mocha says the correct analysis. So ignore the word left. It doesn't refer to direction. It's like left as in I left it there yesterday. That's correct. So there is ambiguity in English. I mean, because left could mean the left-hand side or my left hand, or another meaning is it's a state. It was. So there are two meanings in English, the language of the word left. But however, when you describe this problem involves left-hand side, left rotation and right rotation. But so it's ambiguous. So if you are writing a technical documentation or if you are writing a puzzle, you should avoid phrasing like that. But you could argue that the guy intentionally phrased it that way, so it kind of like add to the confusion of the puzzle. That's not good, because the quality of a puzzle is about the essence of the puzzle itself, not about your like style of writing. I mean, you could make it elaborate like Shakespeare style, but still, anyway, so this is not very good. Okay, this is like a flaw. I find a lot of flaws of the advent of code. Yeah, okay, let's go on. So we're gonna, probably gonna take 2 hours just to finish this. Okay, let's move on. For example, suppose the attached document contain the following rotation. Okay, so this is kind of your input, I suppose. Can you guys see it? Actually, yeah, so you kind of can see it, but let me move it here. Oh, stupid. Okay, so let me think about this. So 0 to 99, and you got, so start at 50. So 0 to 99 start at 50. Then you can rotate left or right. Then you want to know the number of times. So every time you rotate, there's a new pointer, right? So you want to know the number of times when that pointer is at 0. Okay, so you given this bunch of rotations, the following these rotations would cause the dial to move as follows. Okay, the dial start at point at 50. The dial is rotated L68 there, L68. Then it's at 82. Let's compute it. 50 minus 68 is negative 18. Negative 18 plus 100 is 82. That's correct. Okay. Then you do L30. Double check L30. Okay. L30. So 82 L is minus. 82 minus 30 is 52. Okay. Is it less than 100? Yes. Okay. Do nothing. Then 52, do R48. That's plus 48. 52 plus 48 is 100. 100 is equal to 100. So you do modular arithmetics. 100 divided by 100. Wait, let's see. 52 plus 48 is 100. So 100, you want, what is the modular arithmetic? You want to divide it by 99, not 100. Okay. Wait, let me see. So this is off by 1 problem. I mean, off by 1 likelihood of kind of a problem, a trick. So 52 plus 48 is 100. And when you got 100, what do you want to do this here? So modular arithmetic, you have 100 items divided by 100 is 1. Then you want to minus 1. Right, every time you divide it by 100, you got, right, so you want to minus 1, okay? Now remember that. So that's why you got 0. Let's try again. So 0 L5 is negative 5. Negative 5 plus 100 is 95. Okay, 95. So I think we got it. Okay, so just remember, every time you add 100 and you divide it by 100, then you want to minus 1. Is that right? Let's see. Yeah, minus 1, because there's 0 to 99. Right. So if you minus 1, so yeah, I think it's right. Okay. So anyway, so let's go on. Let's move on. Because the dial points at 0 a total of 3 times, 1, 2, 3. During this process, the password in this example is 3. Analyze the rotation in your attached document. What's the actual password? Okay. So we got this number. So let's start to code. Okay. It should be easy. So showing browser. Okay. Start a Wolfram language pad code. Pop it out. So you got this kind of input. So now remember, this is just a sample. Then you have to deal with your puzzle input. So let's copy it. Select all. Copy. Let's see. Paste. Okay, so it's got 4,500 items. Okay, let's make it one line. So how do you want to present this you can, in Wolfram language, you can leave them as is, as symbols, or you can turn them into a string. So so you see, okay, so it's select or copy, okay, select or paste. So 4,500. So you can process them as symbols or process them as strings. Let's turn them into strings because strings is more universal. So okay, so let's do them. Okay, cut, close, and well, input dot text. Okay, AOC day 1. Yeah, I'm too slow. Yeah. So let's just make them at least. Okay, so save it, copy the file path, close it, paste it. Wait, copy the file path. Okay, make it underscore, close it, undo, paste the link there, open it. That's good. So let me think what to do. Okay, so first of all, generate a list of 1,000. Let's just do it easiest as possible. Let's forget about efficiency and elegance. Okay, range 0 to 99. Let's just generate that. Does Wolfram have modular types like ADA? What does that mean, modular type? I think you mean some kind of ring, okay? But Wolfram language can do can have a lot of ways to solve these, okay? So for example, you got a range, a list of 0 to 99. You can do rotate left, okay? Rotate left, okay? Let's say x list equals true, okay? So you can run that 0 to 99, okay? Then that's the output. Then you can rotate left and x list, okay? Let's say 2. Let's say 2, okay? Run it. It'll just rotate the list. Non-atomic expression. Okay, you need to evaluate it because it doesn't know what is x list. Okay, so now run this. So you see this is original and this is a new rotated left by 2. So you can do it this way, and the current index is the first element 2. Okay, or you can do modular arithmetics. Okay, so you can do either one. So let's see what we. So every time you get input, so let's make this a list. Okay, so x input equals to, okay, let's suppose that's the list. So yeah, the easy way to do this is let's just start to code it, okay? By definition, it's not pointing left, it's pointing at 0 still. It's confusing. Does Wolfram have modular? I would take the file in as is. They may make you do more with similar input later. Yeah. Okay. So anyway, I just want to finish this quickly because in the past I start to be efficient, be elegant. Then it's like 2-3 hours and we still didn't finish. So for live stream, just show how it works because show the basics of Wolfram language. Okay, so you got the list. Then you got, this is an example of rotation. Then you got the input. So what you do is so every time you do this transformation, this rotation, every time you do it, you want to check if the first element is 0. Then you want to count. Okay, now there are many ways to do it, but I want to do it in a functional way. So let me think about functional way. It's gonna be just one line, okay, for the whole solution. So if you do the imperative way or procedural way, what you can do is that you do a for loop and you do operation, you do one operation, then you check if 0 is the first item. If it is, you add a counter. Result equals to 1 plus 1 plus. Right? Then when you finish, you check what is the result. That's your answer. That's when you do a for loop. Okay, but in Wolfram language is predominantly a functional programming. Okay, functional programming way. So how do you do this functional programming way? Okay, so you want to do this process. You want to do all of them, no exit. Okay, so you can use map. Then okay, so let's go look at my Wolfram language tutorial. Okay, so not to do. So let's go to Wolfram language tutorial and the Wolfram language in depth. And let's go to the section string command print string number pooling list variable expression conditional function loop and iteration. Okay, create a table. So you, in this case, you want to find membership. There are many ways. Okay, let me just quickly show one way so that this works. There are many ways to code this. Huang Guan says it's day 8, not day 1. What? What? Am I on day 8? Oh, wait, this is day 1. What the shit you talking about? Okay. So anyway, am I on day 1, right? Day 1 problem. Yeah. Okay. So yeah, let me just think about this, okay? So you got this list of process. So you got this, you want to apply that each time. You want to know how many count it happens. Fold that, fold list. Yeah, I kind of know already one of the way. okay? But it's gonna result lots of memory usage data. So another way, do we actually need this list? I don't think we do. Do we actually need this, a list of numbers? No, because we can just use modular arithmetic. When you use modular arithmetic, how do you know? Right, you don't need to know. You just need to know what's the current number. So you do not even need to rotate the list. You can just use modular arithmetics. So if you use rotate left and right, it's actually inefficient. Okay, coding is always okay. So then we realized we don't need this list, but we need to get to work. So if you don't use a list, then let me just quickly show how this way works, okay? Let me just quickly show. So let's do fold. Let me just show you guys how it works, okay? Fold list. Okay, what is the parameters? Fold. Here's a Wolfram language fx list. So you need a function. Okay, function. This. So what is the first character of a string? Do we have first character of a string? So right, so you can do string match. Okay, so let's just say, let's look at the documentation, string and pattern. Okay, string and a pattern. So what is a pattern? Let's use regular expression. Okay, regular expression is L anything. Okay, L beginning of string. Okay, so if we run that, it will be true. False. String match regular expression L start with L. Why is it false? What? No, that's not right. Oh God. Ah, shit. Very annoying. So we got lots of tedious problems. Let's look at regular expression. Okay. Regular expression pattern, regular example of regular expression, or you can use string expression. So regular expression, ignore case true. So this is regular expression. Okay, so you got a pattern string, captured pattern, regular expression, reference. Do I have a reference? No. So let's look at the Wolfram language documentation. I believe that should be beginning of string. So why is it not the beginning of string there? So do you guys see it? So did we get the order incorrect? String match Q string pattern. What? Why is this false? God. That's a capital L, right? 10 capital L. So this is true. Wait, so run it again. False. Why is that? Oh, okay, now I understand. Right, so the problem is because in Wolfram language, this regular expression needs to match the entire string. Okay, so in this case, if you put the dot and plus, that means anything, then it'll be true. It needs to match the entire string. Okay, that's one of the tricky part of regular expression in any language, because sometimes if it matches part of the string, then it returns true. But in some other circumstances, the expression needs to match the entire thing. So you see that. So that is the issue. Okay. So we got that. So we what do you want to do if this returns, or another way to do it is you just say string equal okay, so you want to extract string and give the nth character. Okay, so for example, string part, in fact, string start. That's easier even. So we are showing several ways. So string part 1, that will return L. Okay, then you can say same Q that L. Okay, that returns true. That means rotate left. Okay, or another way is string start L. Okay, so you can see we got several ways to match your string. Okay, so cut it. Let me just go here, paste it here as a tutorial. Different ways to check first char. Okay, like this would be good for beginners. Okay, so different ways to check. Now why don't we just use that one, because the string start, because that's so that's what we want. So if string start, then rotate left. So a function rotate left x. Okay, then otherwise rotate right. Okay, now the x, you need to extract the number. Okay, so let's write another program to extract number. God. So given a string like that, we want to extract the number. So let's say to expression. So we are showing some Wolfram language specific. Let's see if it does. So it returns a symbol. No. So we want to get the 68. Let's see. No. To expression. No. Yeah, got it. So tedious, a little problem. So let's now to extract the number inside string. There are, of course, many ways. So let's look at it. I don't know offhand. String length, string split, split a string to a list of strings. I don't think so, because list of patterns, split a string by a list of patterns. No. Okay, so string to list of characters. Okay, not exactly what we want. String functions substring by index. We can use substring. Yeah, we can use substring. Then we can turn the string into a number. Okay, that seems the most intuitive. Get substring by pattern. You can also get substring by pattern. No. String join, string insert, convert to string, string template, string match, string replace. Okay, string. Okay, let's just string take. Okay, let's do this. Okay. Do I make sense? Am I making sense? So string take, string take 2. Oh, string take, what is the string negative n, m to n, so give characters m through n in string. So let's see. 2 and negative 1. That should be 68, okay? Then string to number. There's no string to number. Actually, we need to do to expression, okay? That will give you 68, okay? So for example, you can minus 8. That will give you 60, right? Okay, so okay, so that takes it apart. Now fold takes 3 arguments. Okay, so x input. Okay, so the first argument is a function. Now what does the function do? The function will take x X is one of these L or R something. Okay, so first of all, split it into, so this is a number part. So if string, okay, so if string is L, rotate left, but what is the least? So the function takes 2 arguments. When you want to do fold, the function takes 2 arguments. Okay. Okay, rotate left Z list, then okay, is this clear? Rotate left of this list by this number, okay? And this X, this L68 is the X, okay? So we can actually turn it to X. So rotate right will be something similar, just rotate right. Okay, so this is the thing. Actually, we can run this. Okay, so let's yeah. So let me double check one more time. So fold takes 3 arguments. The function takes 2 things. X least and wait. So what is the fold? Fx least. So begin with the least. Let's just run it. Okay, tedious thing. Okay, here is the code. We paste it, so you can see this defines the range, the list. This is the rotate left example. Actually, we don't need it. And here is the input. Then let's just run it, see what we get. Okay, something is not right. We got a comma there, so where is this extra comma? 2 expression. Okay, this is not right. That's right. So copy that again, select all, paste, run. Okay, so instead of fold, let's say fold list, so it shows all results. Okay, that's not right. So what does it return though? Oh, we got this wrong again. Shit. Select all, copy all, paste, shift enter. Okay, incorrect. What do all the Q means? So in Wolfram language, when a function ends with a capital Q, that means the function either returns true or false. Okay, that's it. So such function is called predicate. So in Emacs list, for example, by convention, it's lowercase p. So a function ends in lowercase p. It means it always return either true or false. In the case of Lisp, it returns T or nil. But in Emacs this is not consistent. There are some functions ends in P, but it's not predicate. So, but anyway, in Wolfram language, it's just capital Q, stand for question. Always return true or false, okay? There's from digits. What does fold do? Fold is just reduce, okay? Fold is like JavaScript reduce or Python's reduce. Python reduce, they removed in Python 2. You have to load the library in Python 3. Okay, let me just finish this. This is getting tedious and we are not doing it correctly. God. So, oh God. So let's say, okay, we actually, these two got reversed. Let me explain later. Okay, let me just do this first. Let me explain later. So this, wait. So this actually input should be there and this should be empty. Okay. So this is input and the beginning. Okay, so this is not good. What does fold do? Fold is just reduce. Okay, let me show you. Fold list F. Okay, 1, 1, 2, 3. If you run it, it's gonna, this is the result. Okay, so it's just reduce. Right, so one way is to use fold, but we are getting, God. Okay, I need to think about this instead of just typing stuff. Okay, let me think about this. So the input is this bunch of L right, LR. So every time you feed one input, so this is the input. So this should be input list. So you go through these operations, okay? Then the function, the first argument is a function, and wait. So where do you get the what? Shit. So you got rotate left and rotate right. So this rotate left. So, but where do you get the initial? How do you get the initial Z list? So the function takes two arguments. So the first argument, the function takes two arguments. Oh, remember to start at 50. Shit. So rotate list, can we do start 50? So actually 50 50. So that's kind of that's that. Okay. So I'm not very happy because this trivial thing I got stuck. So I need to think about this. Okay, so fold takes two things at a time. The function. So here is a function there, and here is the input. The input is a sequence of operations. So every time the function gets operation, so the function takes two things. Oh god. The function takes two things. The function has this is very bad. So let me just look up string take. So regular expressions. So iteration. So every time you do this step, it depends on the previous state. So every time you save a state. So what is the initial what? My current problem is that how do I get the initial list? Or you can use recursion. Let's see. Fold takes this bunch of steps. Yeah, so this is very bad. Or do we use nest? I do think it must be imperative. No, I don't think so. Okay, I think there's a. I'm stuck somewhere. That's what we are doing. We are computing. But let me just get this to work. Okay. So let me just get this to work. So the function takes two arguments. One is the current state. The second argument is the operation. So the current state, so operation. So the current state, you need to add, wait. Wait, this is not right because you are not getting the current state. It's something simple I'm missing, okay? So select all, paste, return. Yeah, so I'm missing, there's something simple I'm missing. String or list of string expected, position of string start. Okay, so something simple I'm missing. So, oh yeah, so this is n. This is, actually, this is X operation, okay? So that, so the function takes two arguments. Okay, so this X is that. Okay, now it's better, but it's still not correct. Because we still have the problem. Oh, that's right. All we have to do is to add. That's right. We need to add the initial state here. So something like this, okay? Yeah, so I know what to do. Okay, so wait a second. Hold on a second. So yeah, we were right in the beginning. We need to put an X list there. Okay, something very simple. So let's try select all, paste it, shift enter. Okay, it's better, but something is wrong. Okay, so what is the problem? String start null L. So we got a null somewhere. So the function, so that's a function, and starting with X list. What? That's right. So what is the problem here? So select all, paste, shift enter. Oh, you got the extra comma there, you see, red. So that is why. So there it is. That is got extra comma, okay? Now select all again, copy, select all, paste, shift enter. Fantastic and beautiful. So this is the final result. But however, we want a list of all steps. So we use, instead of fold, we use fold list. Okay. So this here is just example. Let me put it back. Let me for educational purposes. Okay, this is how fold works. So for example, this list, let me just, this is what confused us before. So ABC, for example, ABC, run it. Okay, so that's the result. So let's indent it so it's easy to understand. Okay, so this is how fold list works. Now fold just return the last item. Okay, so for example, let me do it again. Okay, that's fold. Fold list just return all steps, make them into a list. So similarly, fold returns that, which is just the last item. If you do fold list, it returns all intermediate steps. Again, fold is just like reduce. JavaScript and Python. Okay, so now put it back, syntax correct, showing browser. So we explained string match, same, and string start, and we explained fold. And now our code, this works. So let's do it again. Copy all, select all, paste, shift enter. So it returns all intermediate steps. So now we just want count in this big nested list, how many of them start with 0 in front. Okay, so you can see there's 1 0. Go down, there is 2 0. Go down, there is third 0. Okay, so we want count. So this is the result. So result equals to, now let's count. How do you do count? So far so good. Answer my question without seeing them good intuition. Yeah, show all state, that's right. Can you do the fold to the fold list? Yeah, so okay. So now let's all we have to do is count. So let's see Wolfram language count. Okay, so Wolfram language recursion. Now let's hold on a second. Let's copy showing browser today's talk show, and let's copy all the things we talked about. So recursion and make a link so later on people can easily better see what we've been up to. So in regular expression, paste it there, and get substring by index, paste there. Okay, and close, and then we need to go to Wolfram language tutorial again. Now we want to count of a list. Okay, so let's go to the list section, list, and introduction to list, and then we got list position, nested list, list level, list operations. Okay, we want some kind of count. So get parts, add elements, delete elements, change elements, check existence, join, union, intersection, difference, minimal, maximum, filter, sort, flatten, rifle, rotate left, padding, list, partition, reshape, split, gather, transpose, iteration, scan, fold, loop. So where's the count? Shit. Count. Okay, so count or tally. So where would that be? List, minimum, maximum. No. Create, get amount. So count. Check existence. Okay, maybe that's check existence. Member queue count. Okay, there. So count, expression, and pattern. So count by pattern. Okay, so let me do that. So today's talk show, search pre. Okay, so let's do an example. So let's count. Okay, count a list. Let's say 0, 1, 9, 88. Okay, by a pattern. Now, what pattern? Pattern would be that anything dot dot. Okay, I think that will return true. Wait, so count a big list. This is one of them. This is two of them. Let's say start with 7. And let's say another one start with 88. So we got a list of 3 elements and count by this pattern. Run it. Syntax invalid. Okay, so this is not a valid pattern. So now we need to go check pattern. Pattern matching, count, level spec. Yeah, so we need to check pattern. So let's go to the pattern. Yeah, 0. This should be 0, 0 means 0 or more. Okay, I think that like that. Delete that, run it. It returns 1. That's correct. Now let's try again. Now let's put one more here. Let's say 3. Okay, now it'll return 2. Correct. Okay, so this is an example of count. And if you don't know, you click on pattern, you can see all the pattern syntax. So we are using 3 low lines. So 3 low lines means 0 or more. So you can see, let's see, literal expression pattern, any expression pattern, which is 1 low line. Then you got blank h means any expression but with a head h. Okay, then you got a pattern, named pattern. So given a pattern, you can name it so that when you do replace, when it matches, you want to do some replacement, you can refer to the name, just like regular expression. Okay, so then sequence of 1 or more expression, that's double low line. Okay, the full syntax name is blank sequence. Okay, now sequence of 0 or more expression, that's triple low line. The full name is blank null sequence. Okay, so we are using here triple low line. That means, so we got the list, then it's 0 or more. We just care. We only care if the first one is 0. Okay, so that's how count works. Syntax correct, showing browser. So we got the count example. Okay, we got something extra there. Let's remove that. Put it back, syntax correct. Now go to our code. Now you just want to count this result. Okay, so count, count, yeah, count this result, and pattern is 0 followed by 0 or more expression. Okay, so select all, paste it, shift enter. So 3, the answer is correct finally. Okay, this is kind of inefficient but quick, very fast. You know, this got just 3 lines. Okay, so result is 3, that's correct. Now we need to do our user input. You know, let's do this again. So, but now we got our code input. Let's see, day 1 input. Okay, open it, select all, close it, and then let's go jump out to our code. Then the input is this. Okay, put a semicolon so it suppresses the output so it doesn't print a bunch of things. Okay, so they delete that. Okay, and this original list we don't need, put a semicolon. Okay, so this is the input list. I mean, this is the log 0 to 99. Here is the input, and next result, and we can run the whole thing. Okay, copy it, go to Wolfram Language, select all, paste, shift enter. 1135, is that correct? Let's check. I'm pretty sure it's correct. So let's go to the advent of code. Paste 1135, submit. That's the right answer. You are 1 gold star closer to decorating the North Pole. Okay, so oh my god, that's horrible. Sorry, I got a cold. So we finished this. Answer my question. Yeah, so we finished this. How long have it been? 1 hour exactly. Oh, 90 minutes actually. So we finished coding this in kind of the most intuitive way. We didn't even use modular arithmetics. We could, you know, but the actual, when you start code it might take an hour. But in principle, it should be just 5 minutes, because when you use modular arithmetics, you don't need to keep this list of 0 to 99. And also, our approach is very inefficient because we generated the entire list, you know, this 4,000 times. So we have a list of 4,000 0 to 99. So it's, you know, it's very inefficient, but it's actually the most intuitive. Should I optimize it? No, because I realized the advent code is, you know, they don't care, you know. So I think that's it for today. Then there's part 2. Let's do it some other day. Okay. Any more questions? Well, part 1. Do you think you could explain how it works? I think I understand, but functional isn't my native. So, well, I mean, okay, so let me try. Okay, so you generate a list from 0 to 99, right? And you rotate it so that 50 is in the front. That part is clear, right? Then you got a list of input. These are rotate left, rotate right, you know, a list of operations, right? So one is X list, and the input is X input, okay? So you got two things there. Then what you do is you use the fold operation, okay? So fold, so this fold takes three arguments. The first one is the function, what you want to do. The second argument is the original input list, 0 to 99, starting at 50, okay? Then the third argument is the input, is this operations. So fold, let's refresh. So fold, you should understand what fold does. It's right here. It's also in JavaScript and also in Python. So if you don't know about functional programming, you should master fold, also known as reduce. There's a lot of tutorials because it's also in Python and JavaScript. Okay, that fold is one of the, it's a fundamental general purpose way to do any loop. So in other words, any loop whatsoever, however complicated, imperative loop, for loop, you can write it using fold, also known as reduce, okay? And that's what we did. So fold, in the simplest form, you give a function, the function will takes two arguments, and each time it takes one thing from the list, then return a result. Then the function will feed that result as the first argument, then take another thing from the list of input. So in a sense, it's keeping a state. So the function every time return a state, the state of the loop, then take a new input from the list. Then it returns another new state. The state is fed to the function as first argument. Then it takes another item from the loop, specific input in the loop. So every time it just take the previous state and take another new input, returns a new state, then the function take that state again and take a new argument. Okay, so that's essentially fold or reduce. And in Wolfram language, it has something extra. It has something called fold list. So instead of just returning final result, it returns all intermediate steps. So every time a function takes a state, it adds its one element in the list. Then take the state and take another new item, return a thing, which is a state, that's a new item in the list. So fold list is just like the history of the fold, okay? So here's another example with the initial value. So if you are not familiar with fold or reduce, you should spend time, okay? Now, if you understand fold, then our problem becomes easy to understand. So we are using a fold list, so that returns all steps, okay? And okay, so God, this this slows down, this long line slows down Emacs very, very much. So let's make it, yeah, this way is much faster, because otherwise when Emacs has a long line, every time you move cursor it takes a second. So now it's much better, okay? So anyway, so I'm just returning all steps. Then, so it's a huge list. Each element of the list is one of the 0 to 99, okay? So you can see. So, okay, so it returns this huge list. So 4,500 of them. So this is the first element in a list. So you can see this is how we start, 50, 51, something. Then show more, let's show more. Second element in a list after one of the rotation operations. So it's this one. And so are you still here? Do you get what I'm saying? So then another step, so there are 4,500 items. So once you got this huge list, then you want to count them. Which one of them start with 0? Yeah, so that's so you got 1,135, okay? And this is not efficient, but we get the things done. Okay, so this count is another interesting thing in Wolfram language. It uses pattern matching. So again, it's not procedural. When you do procedural, you do a for loop. You do a for loop on each, then take the first element, check if the first element is equals to 1. If it is, you increment a counter, counter plus plus. Then at the end, the counter is 1135, right? So, but in functional programming, you just have this single function count result and use a pattern. The pattern is whatever list starting with 0 and followed by 0 or more items. So there are 3 of them. Okay. Thank you guys for watching. Thank you guys. So if you like my stuff, go to xahlee.info. Okay, Xah Talk Show, Xah Lee Code, xahlee.info, HTTP no S. And you go to the bottom, you go to lots of stuff. You go to the bottom, you can Patreon me, PayPal me, Amazon gift card me. Okay, thank you guys. Bye guys. Go over the function. Well, the function, are you late? Because we went over the function. So the function is just this function, okay? If you take it apart, it becomes easy. So the function, first of all, it's got 2 arguments. The function takes 2 arguments. So I name them list and I name them operation. Okay, so the function, so this is like a lambda in Lisp or in Python. This is a lambda, okay? This is a function of 2 arguments, okay? Now, then it's simply a if statement. If string begin with L, the string, the X operation is a string, right? It's one of the L or R. Right? So if it begin with L, then you do this line. You rotate left of the list, which is the previous state. Remember, you see, that's the list and that's the operation, you see. So if it's beginning with L, then you rotate left. Then how many times? 2 expressions, string takes, operation from second to last, which is what you get is the number. So you just rotate left that number of times. So if it's L. If it's not L, then you do rotate right. Exactly the same thing. So the function each time just, if the input is L22, it just rotate left 22 times. So it's very simple. Okay, bye guys.